I'm Justine. You already know that though, but like whatever. Okay, so my purpose of making this video is to speak to you guys or teach you guys about compressed gases and matter. So let's just start it off with saying I'm not going to talk about farts because that would be immature and silly. Okay, I'm not going to play by the rules today. I don't care. It's the easiest way to explain it or for someone to understand. Say we were in this room and it's not a big room. It's like just a kitchen, right? You can't see. Okay. Yeah. It's maybe like six by 6 by 3 whatever, 6 by 3 meters wide, or the area is that much. And say like there was one person in this room and he or she, whatever, like farted. It wouldn't be considered a compressed gas, I guess. I mean, in the room, because it's like, maybe it is, but like not as pressured, right? But if this room was full of like more people, like Jack, Jill, Rose, Peter, Luke, John, just a bunch of people are in this room. It's like really packed, and they all just simultaneously fart at the same exact time, like, and it has like the same density, and like everyone just farts the exact same. And we're in this room, and the air is trapped, right? The doors are sealed, everything's just sealed. That's considered a compressed gas if you think about it. And as soon as like someone cracks a window open, that gas is being let out. It's kind of just like this aerosol can. All the farts are stuck in here, and as soon as someone cracks the window or pushes the button, the air just at a high like pressure volume is like forced to let out the air from the room. So that's basically like the basics of like the compressibility of gases. Okay, as I was saying, there's 3 states of matter, or whatever you guys want to call it, whatever. Okay, so there's gas, liquid, and solid. And in each of these little states, the particles inside are really different. So in a solid, the particle, like say these 2 things right here, they're particles. Just they're really zoomed in and like huge, whatever. They're particles. In a solid, they're just like stuck together, like this. Like, you know, there's okay. So as I was saying, the particles in a liquid kind of look like this. This is my This is my Mary Kay palette. I use this for, okay, no, I'm joking. But yeah, if you look closely, you see those little dots everywhere? Those are my particles. And this is kind of how they look like in a liquid. This is a very viscous liquid, by the way, so you can't really, it's not like a liquid, but whatever. That's how they look like. That's a visual representation. And a solid is basically just, using my makeup to show you guys, say these are just like they're super zoomed in. Like these are 2 particles right here. They're just stuck together. Like there's this thing called intermolecular distance, and in a solid there's no distance at all. They're stuck together because it's a solid, you know, like the particles are stuck. Like this thing right here is a solid. They're stuck together. If it was apart, this phone would be Jello or like water. Like it has to be. That's like the basis of like everything. It has to be stuck together. And in a gas, I can't really give you a visual representation, but just they're flying. They're flying everywhere. Yeah, so say this is a particle, it's flying. This is another particle, it's flying. They're just everywhere, bouncing off walls. Everywhere. There's nothing constraining them. Constructing. Never mind. Whatever. Nothing just holding them back. Like they can go wherever they want, unless, see, that's where compressed gas comes in. Unless they're compressed, then all these flying particles going left and right, bouncing off walls, are forced to be, like, they're squished into a smaller container. And that's where aerosol cans come in. So, one second. So, this is an aerosol can. And, most aerosol cans, like when you look at them, like this Febreze here too, this is my hairspray, they're all have something in common. And it's, let me check, there's a women's symbol that they all have in common. I think it's, like, what does that stand for again? They all have the same one. It says it's extremely flammable, or there's a risque d'explosion, which I think that means that there's a risk of explosion, so don't drop it or shake it like crazy. And they have to put these little signs at the bottom because it's a compressed gas. The particles inside are under a lot of pressure, so instead of just, floating around, having the time of their life, they're restrained. I don't know if I'm using the right wording, but whatever. I'll correct myself in the video. They're just stuck in this little place. So when the button for it is pressed, there's I probably shouldn't have used the bug spray, but oh god. So, because all these particles are under so much pressure, when the button is sprayed, the button is pressed, the material inside just flies out. It can go like, I think this can go a few meters. I don't know how far. I don't know if you guys can see it on. You guys can't see it. But from what I see right now, it's like flying. I don't know how far, but like if there wasn't any compressed gas, when I press this button, the liquid inside would probably just drip down the side. It just come out and like fall straight down. But there's so much pressure, so when you do press it, it just flies out. So that's great. So props to whoever invented compressed gas. You guys saved me from my bad hair days and from getting bit by little mosquitoes and from really nasty smells in the washrooms. Okay, so I'm gonna make this like really simple. I'm gonna show you how to compress a gas, or if a gas can be compressed, a liquid and a solid. So first I'm gonna start off with my solid. And this, by the way, this is a syringe that like babies use, or like, I don't know, I guess adults use it too, to like take medicine. They like pour it up and then push it out. But this is gonna be my tool so that I can show you guys my experiment. So this is a solid. This is the end of a pencil crayon. I just chopped it off and for this experiment. So I put it in my syringe, put the top on, and I'm gonna push it as hard as I possibly can and cover the end. So watch carefully. I'm pushing it right now. And it won't go anywhere, right? It's not gonna get compressed. Like, you can't compress a solid because it's already as compressed as can be, you know? It's a solid, you know, the particles are already stuck together. You can't push them together even any more than they already are. So that's the first experiment. Second experiment I'm gonna show you is with a liquid. So, oh no, that's not gonna work. I forgot that I can't do that. Okay. So, watch. Syringe. You guys can't see this while I'm sleeping. Okay. Ready? I'm gonna put some more water in here. Okay. So you guys see how I fill it up with water? I'm gonna put my finger on the other side and push it. I don't know if you can see it up close on video, but from my point of view, it like closed a little bit, like not too much. It compressed a little bit. So that's water for you. Now we have air. Okay, so I'm gonna get my syringe, grab some air, close it, cover one end with my finger. Watch carefully. Oh, this is gonna break. No, we're good. Ready? So cover one finger, and I'm gonna push it down as far as it will let me. And if you see here, it compressed quite a bit. My finger is covering the other end, so no air can be released. So yeah, the difference between the liquid and the solid was that the solid did not compress like whatsoever, like, not even an ounce or a tiny bit. And the liquid, it compressed like a little bit, like barely, like it didn't even show. Well, a little bit it showed, so that's how. Okay, whatever. And the gas was able to just compress to the almost the very end. Like it was able to hold a lot of particles inside, which is pretty cool. Yeah, in case you guys are like curious as to where I got all my information from, or most of my information from, I advise you, or you are just curious about compressed gases, I advise you to read the McGraw-Hill Ryerson Chemistry Grade 11 textbook. I'm not sure if I said that in the correct order. But yeah, I advise you to read this because it's really informative. And more specifically, if you want to learn more about compressed gases, I say skip to chapter 11, properties of gases, and then chapter 12, which states like the gas laws, like Boyle's law and Charles's law, and they help you understand like just how the particles move and like when they're heated, what can possibly happen. So if you guys are curious, just check it out. I feel like this is how my face would look like if it was compressed. Last example of a compressed gas, I swear. So yeah, this is my puffer. Don't worry, it's like expired, so like it doesn't matter if I waste it. Like they managed to fit at least 200 puffs into this little thing. Isn't that incredible? And there's still more in it. I can't use it because it's like old. 2016. March 2016 was the last time I was able to use this, so I don't know why I still have it. It's hard to let go of things. This is really fun. Can you leave me alone? Come say hi to my chemistry teacher.
Hi.
Okay, get out.
I love my sister
Get
so
out!
much.
Oh my god!